Hi students, please pause the video and take time to go through the class instructions before we move forward. In today's class, we are going to cover the following topics: history of JavaScript and write two very small programs. I would not be taking a very deep dive into the history of JavaScript, but I do prompt you to watch the movie The Code Rush. The movie highlights the thrilling rise of JavaScript.
Less than 3 years ago, a small team of engineers at Netscape Communications created software that made surfing the internet easy, and in the process, changed the face of computing.
Let's begin with the amazing, fascinating history of JavaScript. JavaScript was created by Brendan Eich in mere 10 days in May 1995. The original name of the language was Mocha, then changed to LiveScript, and finally JS. In year 1997, ECMA, which is the European Union Computers Manufacturer Association, standardized the language. Well, is that all about the history of JavaScript? No, that's just the beginning. Let's begin with browsers. JavaScript is a programming language which works in the browser and now outside the browser as well. In this section, we would be splitting open a browser to understand what happens behind the scenes. Browser has two parts. One, the user interface, which helps user to record an input and navigate. And second, the engine which powers it. The user interface simply includes what we see on any website and helps us to record an input. That can be a mouse click, a form submission, a key press, and so on. On the other hand, the engine of the browser helps us to process these requests. So here, user sends a request to firstpost.com in the browser by entering the URL in the address bar, and in return we get a response from the server. Now let's look into what kind of response do we get in return. So the response includes a DOM, which stands for Document Object Model. Now please note that the DOM is different than HTML. So what is DOM? DOM is basically a hierarchy of nodes which comprises of parents, childs, and siblings. And HTML is the language used to code the DOM tree. So we are now wondering, when will JavaScript come into action? The browser loads the DOM and the JavaScript engine processes the JavaScript behind the scenes. It's time to skip the browser and go behind the scenes. In order to do that, we will set up a minimal and basic environment. The prerequisites include the following. We will be using a simple native JavaScript boilerplate. The folder will be simple and only include an index.html file and a script.js file. We would be using a basic code editor. You can either use Visual Studio Code or Sublime Text, any editor of your preferable choice. You can download the files from GitHub link in the description. Now open the index.html file in your preferable code editor, and you will notice the HTML code which includes the tags which form the DOM tree that we spoke about earlier. One of such tags is the script tag, which links the JavaScript file to the current working project and executes the JavaScript code inside. Now open the index.html in the browser. Your default browser might be Firefox, Mozilla, Chrome, Safari on the basis of your settings. We in this project, however, would be using Chrome and suggest you to use the same to follow along with ease. Now right click and select inspect from the drop down menu. We see our message logged in the console which tells us that the code is working. Now that we have tested out our environment, let's write some basic JavaScript. Writing basic functions in JavaScript. The following part will not be an explainer about JavaScript functions, but will give you a brief overview of what are functions and how to write one. In order to understand JavaScript functions, you need to have basic understanding of the following: functions, values, variables, and return statements. Let's understand each one by one. Functions are modular building blocks of program logic. So, what can we do with these modular building blocks of program logic? Let's find out. Following is an excerpt from the book Secrets of JavaScript Ninja by John Resig, and it says that one of the reasons that function and functional concepts are so important in JavaScript is that function is the primary modular unit of execution. The second point says that we will see that having functions that are versatile and powerful constructs will give us a great deal of flexibility and sway when writing our code. Now let's just go over the keywords that we use to define a function. First keyword is modular, employing or involving a module or modules as the basis of design or construction. Modular housing units. Computing. Any of a number of distinct but interrelated units from which a program may be built up or into which a complex activity may be analyzed. A networking module. A module can be a set of independent components which can be combined in multiple ways to make a meaningful composition without breaking or affecting the independent behavior of each component. Promoting flexibility, reusability, and independence. The only limitation is that to achieve a meaningful composition, we need to understand behavior of every independent component and the final composition that we are trying to achieve. The best example of modular systems is the Lego blocks. They promote flexibility, reusability, and independence. The only limitation with modular approach is that in order to achieve a meaningful composition, we need to understand behavior of each independent component and the final composition that we are trying to make. Now let's get back to function definition. Functions are modular building blocks of program logic. So by building blocks we mean they are the independent cellular unit which make complex structures. We will be taking a deep dive into program logic later in the course. For now, you need to understand it as direction boards you see while you're on the road. Just like the direction boards help you to decide which direction to go, the program logic helps the code to execute and return an absolute value. Now let's understand the syntax of a function. A function contains a function keyword, a function name, parameters, and the function body. We are going to write basic functions on mathematical arithmetic operations like addition, subtraction, division, and multiplication. Here in the following example, you see the function written in the same syntax that we discussed previously, starting with the function keyword, sum, which is name of the function, a and b, two parameters passed to the function, and a return statement inside the function body which returns a value a plus b. Now we are going to go through a small excerpt from the book Eloquent JavaScript. Previously, we discussed the prerequisites required to understand writing a basic function. The second requirement was values. What are values? So, inside the computer's world, everything is data. You can read, modify, create, and delete data using operators. Whatever is not data does not exist at all inside a computer. Uh, Data is stored in form of long strings of numbers called the binary numbers, which are represented using binary notation. As our computing devices only deal with digits on a cellular level, we also call our computing devices digital devices. I hope that makes a lot of sense now. So, by that, what it means is that if we are working with any computing device, I'm not talking only about computers, I'm talking about any computing device, be it a calculator, be it a small interface that you see in your washing machine, be it a temperature calculator, or any digital device. At a cellular level, every single piece of information can be broken down to bits, a shorthand notation of binary digits. Okay, values. Imagine a sea of bits, alright, not well, an ocean of them. A typical modern computer has more than 30 billion bits in its volatile data storage. Non-volatile storage, the hard disk or equivalent, tends to have yet a few orders magnitude more. So now that at a cellular level we are managing not trillions, not millions, but multitude of 30 billion bits, it's high time we have a way to manage these cellular units. Values to our rescue. In JavaScript, to be able to work with such quantities of bits without getting lost, you can separate them into clunks that represent pieces of information. In JavaScript environment, those clunks are called values. Though all values are made of bits, they play different roles. Every value has a type that determines its role. There are six basic types of values in JavaScript: numbers, strings, booleans, objects, functions, and undefined values. To create a value, you merely invoke its name. This is convenient. You don't have to gather building material for your values or pay for them. You just call for one and whoosh, you have it. They are not created from thin air, of course. Every value has to be stored somewhere, and if you want to use a gigantic amount of them at the same time, you might run out of bits. Fortunately, this is a problem only if you need all simultaneously. As soon as you no longer use a value, it will dissipate, leaving behind its bits to be recycled as building material for the next generation of values. This chapter introduces the atomic elements of JavaScript programs, that is, the simple value types and operators that can act on such values. Now, having understood values enough, we automatically understand where do variables fit in. Variables are the containers which stores these values. We would be taking a much deeper dive into values later in the course. For now, let's move on to our next requirement, which is the return statement. We discussed previously about values and functions. The concept is simple. In function definitions, the return statement is used to return a value, and if not stated, it returns the default placeholder value undefined. Let's go through 3 not to forget pointers about return statements from a blog by Codeburst. So, rule number 1, every function in JavaScript returns undefined unless otherwise specified. So, to test this, we are going to create an empty function and then invoke it. And then we will see that as a result, it will return undefined. So here we open our console. So as you can see, if we go ahead and invoke the function do nothing, it simply goes ahead and returns undefined, which is one of the values that we discussed previously. The second rule is the return statement ends function execution. This is important. Using return causes your code to short circuit and stop executing immediately. Let's understand that by the following example, where we have two return statements in our test function. Function test, return true, return false. So there are two statements. JavaScript reads and parses the code line by line. So when the syntax parser reaches the line return true, it stops executing the function. It terminates the function execution and returns true. Rule number 3 says return statement returns a value to the function caller. Again, it's similar to rule number 1, where by default it's returning undefined, but in this we are explicitly mentioning the value that the function shall return. So in the following example, we are taking a variable double, storing a function definition inside, which says function number return number multiplied by 2. So every time the function will be invoked, it will return the number 6 and the value type will be number. Now let's go back to writing some very basic code. So here we are writing a function which adds two numbers. Very simple, nothing complex. Function keyword, function name, which is sum, takes two parameters a and b, returns a plus b. Again, the value, which is a number, and the sum of both the numbers. So now we will simply check the result of our statement sum 4 plus 5 in the console, and it prints out the number 9. Now let's do some hands-on coding. The following part is self-explanatory, but I do recommend you to pause the video wherever necessary, and do not hesitate to ask me any questions if you have. Let's put on some good music before we start. So here I've just mentioned few very basic exercises, add functions, calculate areas, which you can easily do, and everything is basically just mathematical equations, and whatever fits in a mathematical single line equation you can make a function out of it by returning the statement. You just need to know how to put values inside a variable and then return the entire equation out as a result. I want you guys to try it out with more equations, more examples, and in these exercises there are few bits, few incomplete elements for you to practice. So ensure that you go ahead and fill those missing elements and print out the results as I have explained in the initial examples. So this example is a complex one, and let's roll. So it's a palindrome. Any of you who do not know what a palindrome is, please Google it up. It uh, any word which can be read the same from the beginning or the end is called a palindrome. So our parameter word is gonna be a palindrome, and the output is gonna be a boolean, a true or a false value, and it will check whether the word is a palindrome or not. Our programming logic will ensure that it's as efficient as it can be. So we are gonna save the length of the word in the variable length on line number 5, and then we are gonna calculate the center of the word, and then we are writing a for loop on line number 8 which starts which iterates from 0 to the center, which is the maximum value. It if the first instance of uh, iteration where it's comparing the first character and last character, if the first and the last characters are unequal, it simply returns false. And like we read about the return statements, whenever JavaScript notices a return statement, it terminates the execution. So here, if the condition on line number 9 happens to be true, right there on line number 10, the entire function will terminate its execution and return a false value. It will just simply return a false value. That's gonna be our answer. But if not, it's gonna go on to iterate the for loop over and again, and then it's gonna iterate for I is equal to 1 and do the same thing. If till the center the iterations, no matter how many iterations are there, happen to be true, then after the for loop exits on line number 12, it will come on line number 13 and return a final answer which is true, which will be when the entire for loop has traversed and consecutively checked the first and the last character and the second first and the second last and so on till the center. So like that we either get a false or a true result on the basis of the iterations and the program logic that we have written. Try understanding uh, the entire program logic first and write it in your layman language, uh, just simple native language, no program, nothing, but just try to write the logic and see if you are able to crack the logic first and then jump onto the syntax of writing the code. So now it's your turn to try out the code on your own. I know there is still a lot of missing gaps on the syntax of the language, but do not worry. Right now, just go ahead and copy the syntax. We are gonna learn syntax in depth in the future classes.